Welcome, welcome everyone for the second session of the Ansible Day here at GSC UK Virtual. Really pleased to have Jan on this session, which is leveraging Ansible for implementing self-service automation, GitOps, and infrastructure as code. We had a bit of a chat before, Jan and I have, and it's some pretty good content in there. For those of you that were on the 101 session with Bill, hopefully this will take you perhaps a step back and give you a bit more information, basic information on how you can enable yourself with Ansible. So Jan, over to you. Good luck. And if anyone's got questions, put them in the chat. Jan would like to address them as he goes through. So I'll moderate that. But please feel free to put any questions in the chat. Thank you.
Okay, thank you, Stuart. Welcome on session that Stuart already announced, leveraging Ansible for implementing self-service automation, GitOps, and infrastructure as code. My name is Jan Prihoda. I'm working at the Broadcom for more than 5 years, and today I would like to tell you something about some generic information about Ansible, how you can utilize it for your operations, what is happening on the, let's say, Ansible ecosystem, how we are contributing it, and then I have a few slides as a demo. Unfortunately, this morning our demo environment went a little bit crazy, so it will be just passive slides. But to be honest, it will be very similar to what you would be able to see if I would it live. So share this slide. I think this is something what was introduced last year on the physical conference. If you would like to donate, there are some links, QR codes, and to make some kids happier. So what is Ansible and why you should take care about Ansible? Ansible is a tool, open source tool that enables infrastructure as a code. I think that's the major benefits and major topic for Ansible. Initially, Ansible was developed, I don't know, I think some kind of 8, maybe now 10 years ago. And it was primarily intended to be a tool for automation of operations, maintenance, reconfiguration, whatever, for Linux systems. However, it was very, very powerful almost from the beginning, and many others would like to get some benefits from that. So more and more vendors introduce their own collections that enables you to automate almost everything. So now you can control your networking infrastructure, IT infrastructure, even Philips bulbs or IKEA bulbs are able to be controlled from Ansible. Of course, that's very, very niche and I would say quite fun case, but I think it's a good example how Ansible can be or is universal and can be used for various topics or work. As I said, it's open source, but you can get commercial support, so you don't need to be scared to use it for the business environments and make it as a part of the daily work. What is happening in Ansible regarding mainframe and ZOS is that something like 2 years ago, IBM introduced their ZOS core collection. They have more collections, but today I would like to just emphasize this collection because I think it's very important door opener for Ansible on ZOS. You can work with ZOS from Ansible playbooks as you would do with any other operating system and tool that you would like to use. You may ask what's different from Zoe, and there are differences from the technical implementation. So you then need to lever what is your purpose and how you are building your infrastructure, etc., etc. But you can think about this ZOS core collection as something what you can use to cover basically almost on a ZOS from the operating system perspective. We as a Broadcom last year released a set of I think 7 collections for some selected products that we have. And this January, we released 2 more. So they are all available for our customers. And in my demo, or better say in my slides, on my slides, I will show how they can be combined together. Why Ansible? Ansible is very popular, and it's a tool that is very easy to learn. Of course, the installation, it's not for beginners, but then the usage, it's really simple. You just need to write your playbook, go either into the AWX, which is UI extension for Ansible, or run it from the command line interface and run the playbook that would cover topics or use cases that using standard automation on a platform like, or scripting like shell scripts or X scripts much difficult. So Ansible can be as a tool that can be considered also useful for newcomers, new hires. When you would like to get them on board on ZOS, you can easily utilize Ansible as a learning platform. It doesn't mean that traditional mainframe automation tools are not relevant anymore, because still you are automating off the platform, and there are some or there could be some caveats. So better is to think twice to remove the traditional automation tools from your pipelines or from your work and replace it by Ansible. I think Ansible here is more like an orchestrator than replacement. It means that, as I already mentioned it, you can concatenate tasks across multiple environments. Let's imagine that you would like to deploy your new product code from your testing environment to the production, and in the same time, you need to do some networking reconfiguration. So you can write a script, or in Ansible terminology, playbook, that do all the work across multiple target endpoints. Mainframe, it could be some Linux machines or distributed environments. Networking, you can reconfigure your proxies, hardware proxies, firewalls, etc. And all these things can be done by one playbook almost in the same time. As I'm talking about playbook, you will see it in the next minutes. It's a very simple description of tasks that Ansible should perform on selected environments. These playbooks usually are located on a Git or any other available environment for storing source code management. So you can then gain benefits from that, as you may know from development procedures. So you have a versioning of your playbooks. You can implement code review practice, so more eyes can see more. You can implement instant testing. So whenever you do change in your playbook, you can run some tests to validate or verify that either the playbook is right, or the work that should be performed on the targets is correct. Of course, authentication and authorization, it's very important. And again, using Git as a source for playbooks can allow this very important tasks or behavior. And of course, backups, backout, that's something what I think it's also important. And by implementing this practice, you can be sure that even if something get wrong, you can easily get back in any stage of your process. I have here a set of typical use cases. I would bet that you can bring much more use cases, but let's check what I have here now. As I said, you can easily orchestrate your already existing automation. You can concatenate all the tasks in some huge, or maybe not huge, but some kind of overall workflow that would then allow you to think about things more holistically, not like isolated tasks, but as a one big goal. Very popular use case is to work with certificate in Ansible. So you can create the playbooks and integrate the behavior of the playbooks also with ticketing systems, for example, ServiceNow. So you can easily automate certificate management. And from our experience, we know that for our customers, and I believe this is across mainframe community, certificate management it's quite a huge topic, and Ansible can play a big role here as an improvement and simplification. You can manage your users using Ansible. I know that this is something that many security guys would not be happy, but let's imagine that, or ask yourself how often you are asked to reset a password for someone who just blocked it by multiple tries or forgotten passwords, etc. You can scheduling jobs using mainframe schedulers. So another interaction between Ansible and existing mainframe tools. You can verify that sensitive data on mainframe are or not encrypted. You can work with testing environments. So basically, you can implement also part of the CI/CD pipeline using Ansible. You can install and perform deployment tasks across multiple environments. I mentioned that you can, in one playbook, distribute or deploy code for mainframe, from Linux, for Windows servers, whatever is needed. You can automate them from one place with very similar usage. So you don't need to then learn all these three operating systems. From Ansible perspective, you are just creating tasks, and it's up to Ansible and the collections within Ansible to know what should do from the technical perspective. So I was using a term like Ansible collection. So let's check what is it and where you can find them. IBM's US Core Collection is a set of functionalities. In Ansible terminology, it's a module that allows you to perform tasks on a selected or on a target system. In our case here, I have as an important collection, the ZOS Core Collection made by IBM and still developed and improved. So it's definitely not that project, but very live, I would say. So what you can do with it? You can work with dataset as you are used to do from the green screen, USS, or using Zoe. You can download and upload data from and to ZOS. Again, you don't need to take care of what is happening under the hood. You are just downloading data, and that's it, or uploading, of course. You can work with ZOS jobs. So if you have a job somewhere stored, you can easily submit the job using Ansible collection for ZOS. That would allow work with jobs again as you are used to, but also to allow it to people who are not so familiar with job submission and getting results, etc. Everything this is possible in Ansible, and for that you will use this ZOS Core Collection. And of course, running and execute ZOS or TSO commands, that's something what is I would say crucial, because then by using this capability, you can basically do whatever you want from Ansible. There are, of course, some prerequisites. Nothing is for free, so you need to fulfill this set of prerequisites. You need to have a proper version of ZOS. You need to enable OpenSSH. The reason is that Ansible, as I said, was developed for Linux environment initially, and there the SSH is major remote access protocol, so that it's still applicable here. So you need to open your SSH between Ansible control node and the target mainframe. You need to have a Python SDK in this particular version. And one more important thing is that you need to install IBM Z Open Automation utilities, which allow a lot of stuff to perform locally. I mean, within the USS, but the ZOS Core Collection is built on top of a set of scripts, either Shell or Python from Open Automation utilities, and then ZOS Shell. IBM has more collections, so I just list them here to have a full overview. I know that the IBM is working on getting more and more products onto or into the Ansible. So currently you are able to work with Kix, IMS. You can work with ZUSMF. You can use Z system automation operations, also package manager and hardware management console. IBM definitely is working on more use cases or more products. So I think in future this list will be much longer. And this is applicable for us as well. For us, I mean, as a Broadcom. So currently we have available 10 collections. There is one more, but this is let's say technical prerequisite for all these collections. I will in the next slide explain exactly what I mean. But for products like CA7, Endeavor, and Bridge4Gate, FileMaster, Ops, Spool, View, SysView, NDB, and DB2, you can get the collections from Ansible Galaxy as well. There is only one prerequisite for this, and this is to have REST API enabled for this particular product. Everything else it's solved by this REST API on the mainframe side and by Zoe CLI on an Ansible control node side. I would like to use a pen. Yeah, I hope you see laser here. You should. So on this screen, I would like to.
We do see it, Jan. Thank you.
Great, thank you. On this screen, I have a diagram that should help to understand you how collections and Ansible playbook interacts with Git and with mainframe from Ansible. So let's start from the bottom. Ansible playbook sits in a Git. I already mentioned that. So you can work here on this level as you are used to, or maybe not, but your developers, or if you are a developer, you are then used to. And the Ansible playbook is executed here by Ansible. The playbook is taken from the Git, and that's it. Basically, that's the whole mechanism. And Ansible takes care about executing what's written here in the playbook on the target system on the mainframe. Of course, as I said, there could be much more target environments than just mainframe, but for us, I think mainframe is the most important one. Ansible needs to know what the keywords you are using in fact mean, and how Ansible should handle them. So for that, we are using Ansible collections. As I mentioned in previous slide, we have here a core collection and Broadcom Ansible collections. IBM core collection, as I mentioned, depends on basically SSH, and then there's the open automation utility. So the path from Ansible IBM collections is going through this. And our collections are using CLI, or better say, REST API connection between Zoe CLI and the target mainframe. How it is done? We leveraged the investment into the Zoe CLI plugins for our products, and use this as a wheel on a background for running the other collections. So we have one collection that consists of special module and Zoe CLI core, and every other product collection is using this core collection. For example, this could be, I don't know, SysView or CA7 collection. So inside this collection, there is a description or definition of all the keywords that are available in this collection, and then description how this core collection should communicate together. So when you are using something like when you are using keyword or you would like to write playbook using any of our product, what is happening under the hood? Ansible takes the keywords, asking the core collection, what does it mean? And our collections communicating together. So at the end, what Ansible does is Ansible submitting or sending, or maybe better say running Zoe CLI commands from this Linux environment using REST APIs as you would do it manually. It has some benefits, or I would say many benefits, like for us, but of course for you as a users. Everything what is written in this product collections, it's very similar, and I believe I can say almost the same as what is in Zoe CLI. So if you are already familiar with the Zoe CLI plugins, you would definitely exactly know what you should do in the playbooks using this collection. Also, you need to have proper access using REST API. And if you do so for Zoe CLI from other environments, then this is also already fulfilled, and you don't need to take care anything. You don't need to take about anything else. So now I would like to show you demo. As I mentioned, our demo environment wasn't so nice this morning. So I have few screenshots. But before, okay, wrong window. Let me check it. Okay, Stuart, please, do you see my browser?
Yes, we do. Thank you. Yeah.
Cool. So I don't know whether I'm still logged in or not. Yes, I am. So what you are, well, I will start from different screen. I need to show. Yeah. So this is Ansible Galaxy. This is a space where all the collections from any vendor, individual contributor, fun groups, the collections are stored here. It's open source, so you can immediately go to this address and get information about whatever you want regarding collections, and also learn the documentation, or read the documentation and learn more about the collection. And then using standard Ansible tools, you can immediately download this or any particular collection from this server to the existing Ansible instance. So let's check what's we have here. I mentioned that we have here Kix, IMS, hardware management console, and much more. But as I mentioned, this list is still growing. So in future you will see much more. We are interested in IBM's US Core in this case. So you can see here what's here. Read some basic description and check the content. This is not so descriptive. So let's check what IBM has here on the doc side. Cool. So this is the documentation for IBM ZOS collections. We are interested in ZOS Core collection now, and as I said, modules are the workers that doing the work. Let's check, for example, module for ZOS copy, which basically do what's written here, copying data set to and from ZOS, and accept some definition and description of all each parameters, like parameters, and they are here. I wanted to point you to the examples. IBM has very nice and I would say very descriptive list of examples, so you can see how you can use this particular module within this collection. It's very simple. Source, it could be your local path. Destination, for example, data set. If you are moving local file to sequential data set, you can work with USS and also validate the checksum, so you can then validate whether the transfer was okay or not, and much more. It's really powerful. So if you are interested, what's there, please go to the Galaxy site and check the check the collection. Okay, that's the same. Now, this is how looks the current Broadcom Ansible Galaxy space. I mentioned we have there 9 products plus the Zoe Core collection, and to make it simple for any Ansible user, we follow the same structure as IBM in the documentation, or in the perspective of documentation. So here is not so much content, but you can then go to to the documentation side, and the structure is very very similar. So if I would go, for example, to the CA7, and I would like to run a CA7 job, again, the same structure as IBM has, and we tried to do the same from the naming convention perspective, the same what is in Zoe CLI plugins. So as I said, if you are familiar with the Zoe CLI plugins, this shouldn't be difficult to get orientation here. And of course, some examples. Yeah, our examples not so deep, but if you are familiar with the product, it should be very easy to understand what does it mean to use this collection or any other collection. Okay, now. This is playbook. As I mentioned, playbook sits in Git. In our case, we are running internal GitLab instance, and what I will show you is the playbook that do the following. The name of the playbook is check the JCL stored in Endeavor before submitting using JCL check. So Endeavor is Broadcom's software for software versioning and software development management or source code management, and JCL check is tool for validation of JCLs. Every playbook has something what is called like a tasks. So this playbook consists of I think 5 tasks, and of course some header. So you need to define on which host the playbook is executed, what are the environment variables, and some internal playbook variables. So here I have a variable for Endeavor element. It's basically a name or the location where the JCL sits or is stored. So in our case, we have here element called backup. So the first task is to retrieve JCL from the Endeavor inventory and store it to the local file. Again, it's very simple. Even if you are not familiar with the Endeavor, I think it's easy to understand what is happening here. We have a task to get JCL and store it in this file. This is a name from the Endeavor perspective, some definition of the location, what its type, and how we would like to name it, and that's it. Next task is to show the JCL. What it does, it just show the JCL that was retrieved and stored in this file, in the local file, and show it to the user. It is really just for the debug purposes. Then we would like to check it, check the JCL. So again, name and what collection are we using, or in this case, directly module, check the local file. So local file is this job JCL. Ansible remembers all the locations, so you can just put there just the job JCL. You don't need to put there a full path, etc. And then some JCL check options. To be honest, I'm not familiar with these options, so I just trust our engineers that they are needed here, and that's it. If the JCL check is happy with the JCL, then we can proceed to the next task, which is submit the JCL, and we will be using IBM's US Core module called Zoe Job Submit. Again, source, where it's stored, it's local, and whether it should wait for finish, and that's it. And just wait for the job result and print it. So if all the tasks in the playbook are successful, at the end, job will send some result, and we will see it in the log. So that's it. And now I will go directly into the Ansible. In fact, this is not just Ansible, but it's AWX, which is free and open source UI for Ansible. You can get it also as a paid, and I think now it's called Ansible Automation Platform Hub, something like that. I'm not sure exactly, but definitely you can find it on Ansible site. So
sorry, Jan, can I just,
yes,
and one of the beauties about this stuff is that it comes containerized AWX, so
yes.
you can put it in a ZCX extension. That's something that I've been exploring recently that just makes it a little bit more mainframe centric for the GSE.
Yes, you are right. So yes, you can run it as a container on a mainframe directly. You need to have independent Linux machine. Thank you. So on the left side, there are a lot of menus and options. So I would like to just show some of them, because I think just the description of what you can do here would be for I don't know, half a day, maybe a day. But let's focus on some important stuff. So in this resource section, you have templates, credentials, project, inventories, and hosts. What you can do here, you can, and I will start from the projects. You need to somehow tell Ansible where the code is sitting. So in our case, we are, as I mentioned, we are using this GitLab environment, and you can just note this URL, and basically it's here. So we are saying Ansible that source control is on this URL, and then of course a lot of additional, or a lot of some additional details that are important when we are creating it, or you would like to see what when was done by whom. You can define who can have access to this project, define some notifications. You can integrate Ansible with, in our case, we put it here, Slack. We are using Slack in our company, so we tried in Slack integration. It works smoothly. So you can be notified using Slack or any other platform that is available here, and get any notification regarding basically whatever is running or happening in Ansible. Important is to define job templates. Please don't confuse this with ZOS jobs. It's different, but they are both doing jobs. So Ansible using job term as well. So you will define jobs that, and now it's switched to the templates, that describing how the playbook should be executed. I used the playbook. You can see JCL check job in Endeavor, and this is also here. So this template would run this playbook, and if you don't have rights, you are not able to change it. That's very powerful capability in AWX, that you can build very strong and complex structures for your users, projects, and environments, or inventories and hosts. It means that you can distinguish quite deep who can do what. You can have a group of users that can just run the jobs, nothing else. Other groups can define these jobs in Ansible. Higher level could be that you can have admins that can also work with inventories, can do modification in inventories and hosts, and that's and more and more. So it's very powerful, and I would say also very useful. So I'm talking about inventory. I will jump to this in the next minute. But I would like to say one more thing. If you remember, there are variables, or there was a variable like C, vars, and element called backup, and we have it also here. So again, based on your privileges, you can edit it as a full definition, and then you are able to define a lot of things here. But if you have less privileges, but still you need to somehow parameterize the playbook and the task that is ready to be run, then during the launch, you can define variables that are let's say predefined here, and then this variable is taken by the playbook and executed. Okay, so now inventories. It's really mess here. So let me find the inventory that would be at least a little bit rich. So yes, in inventory, you can define variables on level of inventory. Let's consider inventory as some kind of envelope of or some kind of wrapper around your existing hosts. So you can have inventories for ZOS systems, you can have inventories for Linux systems, you can have inventories for networking infrastructure, you can have inventories technically for whatever you need. And on this level, you are defining variables that are common to all the systems or hosts within this inventory. So these variables will be taken as environment variables for any execution of playbook on this set of hosts. So we have here for systems, for mainframes, and you can also select dynamically which systems or hosts should be enabled or disabled during the playbook execution. In our playbook, we have specifically said that we are running this as a host. We are running this playbook on a host called SR01. However, you can also define that the playbook is executed on top of the whole inventory, and then the playbook will be executed one by one on each system defined here, or host defined here. Host definition looks very similar. You have here variables, name and description, and basically that's it. So let's back here. I mentioned that you can define the various access. So I have here that for example, the full Ansible admin is system administrator, that's clear. But then we have a Sherman who is customization admin and can do just the customization of part of the playbook execution. So for our internal purpose, it has still admin and inventory admin role, which means that this Sherman can operate with inventories. You can group them also into the groups. Currently there is nothing, but again, as I said, it's a very powerful feature of Ansible and better say the AWX. So you can very easily define very complex structure of rights or privileges for users. Now, yeah, basically that's it. Now, if I would run, okay, I need to find it again. It's here, jobs. By the way, you can also schedule the jobs or Ansible jobs. So you don't even need to wait for 3 a.m. In the morning for the task execution. You can just schedule them, and if you are clever enough, and better say your playbooks are clever enough, you can run this playbooks during the night, and you just can wait for successful or messages with successful confirmation. We have something what is called workflows and I think now I am in wrong. Yeah, in wrong window. To be honest, now I'm a little bit lost. Basically, you have the ability to concatenate more playbooks together, and in each stage react on what the result of the previous playbook execution was. So let's imagine that you are deploying a new product code from the testing or some repository to the production. Even if you did everything correct. Excuse me, everything correct, and per your tests, sorry, per your tests and validation should be everything right. Something can get wrong. So for that, the workflows or Ansible workflows are very powerful. In one stage, you can define what should happen in the next stage, and I mean, what happened? If the previous playbook was successful, then the next one can continue with the work, etc., etc. If something get wrong, you can implement playbook that should do the cleanup. So let's imagine that you are deploying a code or binaries, and for some reason on the targets it's not enough space. So what you would do? Delete everything, or it's up to you. But basically you can clean everything what you did, or if you are submitting some commands and something went wrong, you can prepare a playbook that would revert everything what you did, and make it available for the next try. This is also possible by this workflows. But I would like to continue with the previous one. So if now I would go here and execute this template as a job, again it will ask me, and by clicking launch, it would run the job. Ansible job. Again, everything here is stored, so you can go back into the history and check what was happening. You see the names, what systems were used, where the credentials were used, playbook, dates, who, etc. I will not run it, but in my presentation I have a screenshot as a backup that should show the result of the execution. So as I mentioned here, let's imagine that this is a successful execution of this playbook you just saw, and we have here our 5 tasks, right? So first task is to get the JCL from inventory and store it to local file successfully. It was completed successfully. Next task was to display the JCL. Do you remember there was a debug word and show the JCL? So we have a proper JCL. It's really dummy. It's called just this program, but for demo purposes and some testing, it's more than enough. Next task was check the JCL. So again, it was successful. JCL check return successful code, so the playbook can continue. Then we wanted to submit the JCL. Again, it's successful from the perspective of this IBM module. We changed something on the mainframe, so it's changed, but it means it was okay. And at the end, we would like to get the last task was to get some job result. So you can see that this ID or job ID was finished with zero return code, which means the run of the playbook and the task on the mainframe was successful. So if I would go back on this screen, yeah, maybe that would be easier. This 37 lines, and also with some comments and so on. So let's maybe say it's slightly above 30 lines. We are doing this. We are downloading the job from repository. In our case, Endeavor. We are showing it. That's not mandatory. We are checking it. Again, very simple, and we are submitting it, and we are printing the result. So 30 lines of very easily readable code. You can achieve something. What if you would implement this as a JC as a rec script or shell script? You would write definitely much more line of code. And the reason is that not just because of running all the commands that would do the work on the mainframe, but Ansible is solving for you also all the return codes, the communication between each target platform, etc., etc. If you should automate this using scripts, that would be very, very painful, or at least maybe not painful, but definitely much more complicated. And especially if you don't have enough senior staff, and you would like to ask someone, some newcomer, a non-seasoned mainframer, to perform this using Ansible. As you can see, it's very, very simple. And to be honest, you don't need to understand everything in detail, but you can do it. Out of the platform very, very easily. If the job would be wrong, then the playbook would execute like this. and the result would be like this. We are able to retrieve, that's okay. We are able to show the JCL. If you have a sharp eye, you can see what is wrong on this job. And then task is to check the JCL. We are getting error code 4, and now this is slightly messy. So there are ways, I can show it in the next minute, how you can see better log of this job or execution of this playbook, let's say. But if I'm, yeah, if you notice, there is instead of 14, 13, which is the wrong, and JCL check stop it. So the submission is not happening. How you can get better view? I can go here, and I will show it probably on a different example. As I mentioned, we have something wrong on our environment, but how you can get a better result or easy better result for errors? You can click on each line, or better say return of message, or return message from the tasks, and click on it, and then you can see either a JSON message or standard out and standard error. This task was successful, so there is nothing more to return. But if I would click on this, I can not here. Yeah, you can see better formatting of the error, and then it's better if you are debugging what you have here. Initially, I wanted to show something else. So when we try it, maybe it's here, because we have here some issue coming from the Endeavor. So now, if you are familiar with the Endeavor, and even if not, you can easily compare the error message shown here in the, let's say, raw log, and show it here, and you can then easily see the differences, and it's easily or better readable than in this log. Yeah. Now I would like to return to the presentation. So yeah, a few resources. If you would like to easily get to the resources, you can do so. You can follow, of course, the Ansible documentation. It's very well written and with a lot of examples. So you can get a lot of inspiration there, and then links to the IBM collection and our collections. If you would like to basically read it as a blog, I wrote a very short Medium blog post about basically the same. So if someone would like to read it, you can do it here. And that's all from me today. I don't know whether we have any question. Stuart, do we have any question?
We don't at the moment. I did just ask before you were winding up there to the audience. I know that there's a couple of names in the audience I recognise. So if anyone wants to come off mute and ask Jan a question directly, I'd be happy to do that if you just pop something in the chat. So Jan, other than the licensing of the products that you talked about from Broadcom and IBM, everything you've shown today is free, isn't it? You know, is open source and costs nothing other than time to learn and play around with, doesn't it? That's the beauty of this, that it's another level of cross-platform automation that enterprises can lean into. AWX is the free version of Ansible Tower, isn't it? It does take a bit of internal activity, but I've got it up and running on a ZCX container, so that didn't cost me any space in an Amazon data center or anything. And what would you say is the advantage? Because a few people have asked me, you know, I can do most of this stuff in Rex and have been doing for a while. You know, I think you kind of touched on it, but what makes this better of leveraging vendor solutions in playbooks than doing it all yourself?
Yeah, I think I can give you an example that I'm using, and I'm using myself as an example. To write this playbook is for me for, I don't know, in worst case for 30 minutes if I would need to check every parameter of every module and validate whether it's working or not. But if I should write a Rex script doing this same thing using the tools from the Rex calls, that would be much more difficult for me, which means I understand what I'm doing on the mainframe, what tools I'm using, and what the consequences could be, etc., etc. But from the implementation perspective, it's for me much easier to use Ansible collections and to write this out of the platform. I understand that for many seasonal mainframers, this task would be also for the 30 minutes. But we need also think about the workforce on the mainframe. It's harder to get the new people to the mainframe. So Ansible could be, I don't want to say game changer, probably not, but definitely can help them to onboard on mainframe, even if they don't have any detailed knowledge. If the guys that would come as a newcomers to the mainframe would say, yeah, but I know Ansible very well, then that's a win-win for both sides, right? You gain a workforce engineer who can do the work you are doing as well, using different tools. However, these tools are, I would say, nowadays very popular. Ansible is, I believe, really number one on automation and of platform automation. And if I'm not mistaken, and I remember numbers correctly, in the last Arcati research or study, 25% of mainframe users, or at least from the group they were asking, is already using Ansible, and additional 17 is planning to do so in this year. So it means that by end of this year, more than 1/3 of mainframe population or mainframe community on some level would be using Ansible. And if you would ask this question in a non-mainframe companies, you would probably get much higher numbers. And also, if you would ask in the shops where they have also distributed platforms, they would probably or you would probably say to you that they are already using Ansible for managing Linux, networking infrastructure, whatever. So then it's much easier to start working with these guys who already have the knowledge of the Ansible, and using the collections from IBM, Broadcom, and I really believe in the future also from others, and use them for mainframe operations, but deriving them from Ansible. So yeah, that would be my answer.
Good. Yeah. And I'm also seeing that you talk about engaging the different parts of the workforce, that because it requires Python as some of the back end stuff, that we're now writing scripts that are platform agnostic, you know, which I love. You're able to reuse Python techniques from distributed now on the mainframe with the I believe it's a Rocket port of Python, but it's really interesting. So Jan, thank you very much. There aren't any questions. Okay, indirectly, I've been asked one from someone from on the call has reached out to one of my colleagues who's reached out to me. So Jason, I have got a message Okay, so Mark Turner. Mark, I'll put something in, I'll send you an email about that, because our guys have got AWX in a container on ZCX. They had run into some issues, but they were told me that they got them resolved. But there's many Z platform packages were not available. Okay, Mark, I'll pick that up with our internal people for running AWX in a ZCX container. No, you couldn't unmute yourself. I can. Okay, from a time perspective, Mark, I'll pick that up directly. Okay, so Jan, thank you very much.
Thank you, Stuart.
There are a few more Ansible sessions today, so hope to see some of you there. But Jan, until the next time, thank you very much, and to everyone else, have a great time in the rest of GSE. Cheers. Thanks.
Thank you. Bye bye.